got this line 6 spider valve 112. Power light comes on. The display has a bunch of just solid black characters halfway across and then nothing. None of the indicators, looks like there's a bunch of LEDs. At least some of them should be on, and there's none. Then after the tubes warm up, you can hear hiss on the master volume when that's turned up. Presence seems to work. I can hear it on the hiss. No sound from the front plugging into the guitar input. None of the controls have effect. I'll plug into the back. There's a power amp input, and that works. Presence works, but again, none of the controls on the front work. I have seen cases where amps will have a preamp out and power amp in, and the switching contact inside of there goes bad. But this is probably unlikely the case because none of the lights are coming on the front, aside from the backlight and the power light. But I'll just try it anyway. So I'm going from the preamp out to the power amp in to bypass any switching contact that might be in there. Plug into the front again, and there's still nothing. And my initial guess would be it's some kind of main power supply because all these LEDs are off. And it might be powering some of the logic circuitry or the digital control because the backlight's not working right. The menu, there's no like menu system, so possibly the microcontroller that controls this is not getting power. So if we're lucky, it's just a power supply. And then it would be a power supply that's unrelated to the tube circuitry because that's all working. That'd be the tubes would have a high voltage. Here's a look inside. Looks like there's a digital board here, which might be the issue. Right in the middle there is a 7805 regulator. I'll have to check that. There's the board with the tubes. Heater fuse there, it's not going to be that. There's also another fuse in the back panel, but that's related to the tubes, so it's not going to be that either. And here there's it's like a plus minus 12 volt source, and it goes over to the digital board, so I'll check that probably first. Okay, first I ohmed out this ground and made sure it was same potential as the chassis, and basically a short to the chassis. That way I can just clip my multimeter ground lead to the chassis, and then I can measure these voltages with one hand. Tube amps will have quite a bit higher voltage than most solid state amps, so it's more dangerous than usual. So basically it's just a good idea not to touch anything you don't have to touch. Okay, so on this connector there's a little bit of access on the side probe. A little bit of metal exposed there in the middle. And for the plus 12 volt, so we have 0.4 volts where we should have 12 volts. I'm going to try probing here just in case I'm not making good contact. Still 0.4, let go, drops to 0. So that might already be the issue. Check the negative voltage here, it should be minus 12 volts. And we have minus 0.8. And When it seems too easy, you usually want to check that you actually turn the thing on. And then after that doesn't work, you check that you have a power cord plugged in. Okay, confirm that main power is on. I kind of doubt the standby would be needed to check this voltage. Measuring the plus 12. And we got 13.2. Probe the negative 12. Got negative 13.8. So if this is an unregulated supply, that'd probably be reasonable. You can see the traces down here. A little hard to see in the shadow, but it goes to the negative of this capacitor, and then it goes back over to this connector, and those two labels down there are 9.8 volts AC, so we have center tap, the white wire, and then two taps with AC voltage, and that just goes to the main transformer. So this would be just an unregulated AC source. Okay, next step, probably take a look at this regulator. I think this one here is a 7805, so that's a plus 5 volt regulator. Oh, it's even labeled plus 12 in and 5 volts out, so I'll measure that. Plus 12 in, and I can see 13.2 in. And I'll measure the 5 volt out here. It's measuring 5 volts almost exactly, so that's okay. And then we got this LM1086. I'm not sure what that is, but it looks like it might be a regulator. There's a plus 12 volt label, then a plus VFB, which is feeding a capacitor, looks like. So I'm guessing I'll just see if we got plus 12 volts here going in. Then we got our 13.2 volts. And I'll go to the next pin here. And we got 9 volts. And while I'm looking at the power supplies, I'll just take a quick look and probe these with the oscilloscope to see if there's a lot of AC ripple or anything. 12 volts in. And I got this set to AC coupling, so we're only looking at the ripple. Otherwise, it'd just go way off screen. And so 200 millivolts per division. So we got 116 millivolts of ripple RMS. And that doesn't matter so much as probably this 5 volt output. So it's basically nothing. And then we had this other one. Center pin here was the output, and that's basically nothing. And just for fun, I just got this FLIR camera on here, looking at the regulators. So here's the 5 volt regulator is 195 degrees. It's fairly common that those run pretty hot. And that other one is not very warm at all. I'm going to get a center spot setting and just measure it directly here. Okay, got the center spot, put it right on the part. .95 degrees. The micro is measuring 101, 102. This FLIR will do a pretty good job of differentiating between near temperatures. So potentially, like if you zoom in to this ribbon cable and don't get something like really hot also on the screen, you can possibly see a power supply line will get a little hotter than the data lines. But if there's not much current draw, you probably won't see that difference. So I'm just kind of scanning the front panel board. Nothing obvious. Anything shiny silver will also reflect. So I think that's what that spot right there is. Just a plated pad for a ground connection. So that's like reflecting off the bottom and maybe reflecting off something hot. So not much going on the front panel board, but I wouldn't expect much because it's just controls and LEDs. So one thing to figure out would be this ribbon cable. There should be some power supply lines that feed the LEDs and provide reference voltages for the controls possibly. Another possibility is just wiggle on it, and if it could potentially start working if it's an intermittent issue. I've seen plenty of ribbon cables where they have intermittent connections, and if I get a real sharp probe I can actually probe where it sticks out of the connector. Basically right here I can probe each one of those, try to find the voltages. I'm guessing there'd be like a 5-volt supply going up to this board, possibly more. One thing I noticed is that part right there, 225 degrees. And that's just a small part. I'll zoom into it here in a minute. There's the 5-volt regulator. It's up to 227. Or no, 194. I'm on the wrong. There, max 198. That small part again is 226 max. I'll zoom in here. And I also notice a 3.3 volt indicator there. I'm not sure if that means that little pad there, but I measured it and I'm not measuring 3.3 volts. So it could be that's related to the issue. Not too often I see little parts like that get really hot. I'm not even sure what that is. I'll get the part number and look it up. Okay, this 3.3 here, I'll try to probe it. So 0.5 millivolts, so basically nothing. Also notice this trace here is kind of thick right on this capacitor, so I'm going to measure that, see if there's a voltage there. 1.8 volts. And this is the part that's getting hot. This must be a ground here because that's going to this capacitor negative terminal. That's ground. This pin is measuring 5 volts. Going to, looks like pin 1 on this, looks like AUJ2 part. So I should look that up. Okay, so I couldn't find an exact part number match. I did find a partial match though to this. And the pinout seems like it may be the same. And I've got 5 volts in on this input and about 2 volts out. I think it drops to about 1.8 after it warms up, and this is the part that's getting really warm. So I'm thinking that this is maybe supposed to be a 3.3 volt output. And on here it was that C9 capacitor connects to the output of this. And then that might also be tied into this 3.3 marking. And that doesn't measure 3.3. So possibly something is loading on the power supply. So I might try disconnecting a few things to see if I can take the load off that supply and see if it comes back up. Might have to look at some of these part numbers and see which chips actually use a 3.3 volt supply. Okay, so I pulled the digital board out and right away found this resistor had some burn marks on it. R54. And the one next to it, R53, is a 5.1 ohm, I believe. And R54 appears to have the same marking. It's kind of burnt, so it's a little hard to tell, but it's probably the same value. originally, but now it measures about 50 ohms, probably because it's partially burnt open. I just drew this trace here to follow the path, and it looks like the 5-volt rail is connected right to that resistor, and then the other side of it appears to be basically ground. It's just slightly different than the, like this codec ground and chassis ground. So I'm trying to figure out exactly where the lower part of that resistor, that pad goes. It connects to R53, but from there I don't know. Kind of a handy feature on this multimeter, you can short out the leads and then press this null to zero it out. And even with this basic 2-wire method, it's fairly accurate. If you want to even get more accuracy, you can do a 4-wire measurement and use these in addition. But this seems good enough to even measure slight differences in the grounds. And with this setup, I can tell that the ground on that burnt resistor, when I probe that to the chassis ground or any of the other grounds, it's slightly different. And if I probe R53 right next to it and the bottom of this R54, those have basically 0 ohms between them. So I'm trying to find a path where these two points go. So something is causing R54 to draw a lot of current. So the top side of this is connected to 5 volts, so it'd be the bottom side. It's basically near ground potential, and possibly it shouldn't be, because if it is, it's basically a 5-volt supply, 5 ohms to ground, so that'd be 1 amp of current, and which is more than a resistor like that can handle. So it's probably not supposed to be near 0 ohms from the bottom of this resistor to any of the grounds. So that might be something to look for. Here's the FLIR looking at that resistor, about 123 degrees, so basically probably burnt open until it could handle the temperature. So just replacing it would most likely just make it burn up right away again. So I'll basically have to figure out what's shorting that point to near ground. These other hot spots are that one where the red cursor is opposite side of the PCB where that 3.3 volt regulator is sitting, because there is no component right here, it's just heat going through the board. And then I think this other spot was that 5 volt regulator. Okay, so I ohmed this out and it was 0 ohms to here, and this turns out to be an electrolytic capacitor. The other pin is here for that cap. Interesting thing is this is the positive side and this is negative. So my guess would be you have 5 volts here, you should also have 5 volts on the other side of this resistor, and then this is a positive of the capacitor as a secondary 5 volt supply with some extra filtering. You get some filtering because of that resistor and then another capacitor. The issue is it's being pulled down, this pin here, it's being pulled down to near 0, so there's a short on this. Back to the top of the board, did some more ohming out, and on this chip here, starting down here, pin 6 and 8 are both shorted to that capacitor. So potentially if this chip had an internal short to ground, that would be the issue. And it's supposed to be 5 volts going into these pins, and they're shorted to ground, and it's going to pull that supply low. I'll try to find a data sheet on this and see if pins 6 and 8, see what they are. Okay, so I double checked that pin 6 and 8 on this chip are basically shorted to the positive side of this capacitor. And this chip is a 24-bit audio codec. Does analog to digital and digital to analog conversion. And here's the pin out, so it's 6 and 8 are VREF and VA. And then a little description here. VREF is used as a reference voltage for the ADC and DAC. and that should be connected to an external filtered VA, and that could be part of the reason for that 5.1 ohm resistor that's burnt partially open. And pin 8 is VA, and that's just the main power. So both of those pins should be a 5 volt, and they're basically being pulled down to 0. So something is shorted, and one option would be to pull that cap off just in case there's a chance that's shorted. My guess would be it'd be more likely this chip, or there could be something else on the supply. I'd have to do some more probing to find out if there's anything else on that. It seems a little less likely because this is it's intended to be a filtered supply just for this circuit. So it seems unlikely it would be used anywhere else that could cause noise to backfeed into the digital conversion, analog conversion. So since it's easier to pull this off, I might just do that first, just make sure this cap is okay. And then after that, possibly pull this chip off. Okay, since I'm going to use these clip leads to make a measurement, I want to re-zero the meter. Just adding those leads added a little resistance. So basically zero that out. Or actually I have to hit it twice now because it was already zeroed out. So now with the leads shorted out, we have 0 ohms. Okay, now I got them clipped onto this capacitor, and this was a 1000 microfarad 6.3 volt.